We often talk about information as if it were permanent, something that can always be retrieved if we just had enough technology or cleverness. But physics does not actually support that assumption. In the real universe, not all information can be recovered. Some of it is lost in ways that are not just practical, but fundamental. To understand why, we need to be precise about what loss means. There are two very different kinds of information loss. One is practical, the other is physical. Practical information loss happens when information still exists in principle, but is so spread out, scrambled, or inaccessible that recovering it would require impossible amounts of energy, time, or precision. In these cases, nothing forbids recovery except feasibility. The information hasn't vanished. It's just out of reach. Physical information loss is different. It occurs when the laws of physics themselves prevent reversal. When a process is irreversible, the universe does not preserve enough detail to reconstruct the past, even in principle. This is not a limitation of observers. It is a limitation of reality. Entropy is the key to understanding this distinction. When entropy increases, a system loses detailed information about its exact past configuration. Not because the information is destroyed in a dramatic sense, but because it becomes encoded in correlations so fine-grained and distributed that no physical process can gather them back together. The universe keeps track of cost, not microstates. Consider a simple example: mixing cream into coffee. Before mixing, the system contains information about where the cream and coffee are located. After stirring, that information is not just hard to recover, it is physically inaccessible. Reversing the mixing would require controlling the motion of trillions of molecules with exact precision, something forbidden by thermal noise and quantum uncertainty. The information has not been erased from the universe, but it has crossed an entropy barrier that makes recovery impossible. This is why irreversibility matters. Irreversible processes are not just ones we haven't figured out how to undo. They are processes for which the universe does not retain a usable record of the prior state. Once entropy has increased beyond a certain point, the detailed information needed for reconstruction no longer exists in any accessible form. This is why time has an arrow. If all information were recoverable, the past and future would be interchangeable. Events could be reversed as easily as they occurred, but because irreversible processes destroy recoverable detail, the universe distinguishes between what has happened and what has not. The past is fixed not because it is remembered perfectly, but because it cannot be reconstructed. This leads to a subtle but important realization. Information loss does not require erasure. Most information is not destroyed by being deleted. It is lost by being diluted. As systems evolve, information spreads into their surroundings. Heat leaks out. Vibrations disperse. Correlations fragment. The information still exists in some sense, but it is no longer localized or structured in a way that allows recovery. It becomes part of the background. This is why memory always has limits. Any physical memory, whether in a computer, a brain, or a geological record, exists by resisting entropy locally while exporting it elsewhere. But no memory can resist entropy forever. Over time, noise accumulates, records degrade, correlations break. Eventually, the information that once mattered becomes indistinguishable from randomness. This is not a failure of storage, it is a consequence of physics. The universe does not store information the way we store files. It stores information as constraints on what can happen next. When those constraints dissolve, the information effectively disappears, not because it was erased, but because it no longer influences the future. This distinction matters deeply for how we think about knowledge. There are things we cannot know, not because we lack instruments or intelligence, but because the information needed to know them no longer exists in recoverable form. The universe does not guarantee transparency. It guarantees consistency. Once information crosses an entropy barrier, it stops being part of the causal structure that shapes what follows. It is gone in every way that matters. This doesn't mean physics is pessimistic. It means physics is honest. It tells us that knowledge has boundaries, and those boundaries are enforced not by ignorance, but by irreversibility. Some details are erased not by force, but by time doing what time does. Understanding this helps us ask better questions. Instead of asking whether all information can be recovered, the more meaningful question is, which information remains accessible and to whom? To answer that, we need to talk about horizons, places where information doesn't disappear but becomes causally unreachable. My name is Charles Carroll. Thanks for taking the time to listen.